planet Earth, long before the appearance of man, strange landscapes and even stranger creatures.
"65 million years ago, the dinosaurs were the most dominant creature alive on the Earth's surface. They had survived for hundreds of millions of years. Then suddenly, they and something like 75% of all living creatures on the surface of our planet disappeared. No one knows the reason why, but increasingly the evidence is pointing toward an intriguing cosmic connection.
Many astronomers now believe that a gigantic piece of debris left over from the formation of the solar system hurtled in from space at that time and hit Earth. The theory is that it plunged into an ocean and vaporized, an impact that threw into the atmosphere a dense cloud of dust and millions upon millions of tons of sea water. The whole world was enveloped, and sunshine could no longer get through. The result was dramatic and lethal changes in climate. When the skies finally cleared, the terrestrial landscape was devoid of the great reptiles, wiped out by this cosmic collision. Such impacts happen more often than you'd think. This crater in Arizona, a kilometer wide, was punched by one 20,000 years ago. The spots indicate lots more. There'd be thousands were it not for the erosion of wind and rain and ice. The last major incident was in Siberia in 1908, when huge tracts of forest were flattened as a comet exploded 8 kilometers overhead. Most comets safely pass us by, no more than spectacular lights that occasionally streak the heavens. With their bright heads or comas and tails that can stretch back hundreds of millions of kilometers through space, comets have excited men's minds since time immemorial. To discover what they are and where they come from, we must travel away from the sun and out into the dark reaches of the solar system, beyond even the cold, far planets of Neptune and Pluto. It's here that comets lurk, celestial fossils, dirty snowballs no more than 20 or 30 kilometers across, flotsam from the birth of the planets, lonely wanderers. Every so often, and quite unpredictably, a comet takes an eccentric swing towards the sun, attracted by its gravity. At this stage, the comet is still a dull chunk of ice and dust. But when it crosses the orbit of Mars, it warms up. A tail appears of vaporizing ice that streams away from the sun. If Earth or any of the planets gets in its way, a collision. Otherwise, after a few days of glory, it sweeps back again into mysterious obscurity. Some comets, however, become trapped in the solar system in regular elliptical orbits, like Halley's Comet, last seen in 1910 and visible again from Earth in 1986, about one appearance in a lifetime. A meteor occurs rather more often, a flash in the sky, a speck of dust burning up in our atmosphere, gone in a second. This is a bigger and brighter version, a fireball, a piece of matter the size of an egg searing in from space. Millions of meteors enter Earth's atmosphere each day, mostly unseen. But at night, they're often visible as shooting stars, sometimes emanating from a central point, a radiant. like this one in the constellation of Leo, a meteor shower called the Leonids. Meteor showers happen when Earth's orbit passes through dust left behind by a comet. These pictures record a shower in 1983. They were taken by astronomers at the Royal Greenwich Observatory in Sussex with a special light-sensitive television camera. The shower, called the Perseids, happens every August in the direction of the constellation Perseus. And this magnificent shower, photographed in North America, occurs once every 33 years. These stills are an example of how scientific recording and pictorial excellence are linked in the photography of the heavens.
But how do you photograph the stars if you're just an ordinary amateur astronomer? And the answer is fairly easily. And you can use a 35mm camera similar to this one. Basically, all you should do is ensure that the camera is very firmly mounted, for example, on a tripod. You should ensure that the lens is focused to infinity and that the aperture is wide open. You set the shutter speed at the B, that's the brief or the time setting, and you ensure that the shutter is held open for, say, 30 seconds, 1 or 2 minutes. And you get some superb results. For example, if you point the camera toward the pole of the sky, then you'll be able to see that the stars all make these beautiful curved trails. These are in fact caused by the Earth spinning on its axis. Nowadays, there's a very new fast film has just been released, and if you put it in your camera, it's quite likely that a short exposure, say of 30 seconds or a minute, will show the stars as points of light. So indeed, you could actually photograph the constellations.
It'll give pictures like this, the constellation of the Plough, Orion and the bright star Sirius, Scorpius. The film is rated at 1000 ASA. But for astronomical photography par excellence, you must travel to New South Wales, Australia, home of the United Kingdom Schmidt telescope. Here, in the clear skies of evening, the 1.2-meter Schmidt is lined up to offer an unparalleled eye on the universe. It's the only really big wide-angle telescopic camera in the Southern Hemisphere, scanning more than similar instruments in the north. It can see from north of the equator to the South Pole, the best parts of the sky in which to see our galaxy. This giant cosmic camera requires a giant plate, a sheet of light-sensitive glass that may be exposed for hours. To produce a color picture, the Schmidt will have to take 3 separate photographs on 3 separate nights using different colored filters. Its work is directed by the Royal Observatory in Edinburgh.
Here we have a film copy of one of its photographs. As you can see, each photograph is huge and contains an immense amount of information. On some of these individual pictures, you could count 100,000 galaxies, although this one is of a region much closer to home. In fact, it shows an area quite near to the stars in the belt of Orion. And just looking at the plate, we can see the huge swirls of gas surrounding this region and 1 or 2 more familiar objects. Here, for example, is the Horsehead Nebula, and further to the south, a great mass of glowing gas and dark dust, which we call the Sword of Orion.
That was a negative. Now in color, synthesized from 3 filter pictures, look at the same region. And here's another Schmidt picture, the Horsehead Nebula in Orion. The remnants of the Vela supernova. The Rosette Nebula. The Lagoon Nebula. Schmidt masterpieces, the most stunning ever from deep space. And next door to Schmidt, another great shot, another great telescope bathed in starlight.
This is the 3.9-metre Anglo-Australian telescope, and as the name suggests, this is a joint venture between Britain and Australia. This is by no means the largest telescope in the world. It's situated in Russia. However, this instrument, with its very precise drives, excellent optics, and use of sophisticated electronics, is probably the finest telescope in use on the Earth today.
What Schmidt is to the wide angle, the Anglo-Australian is to the close-up. The Helix Nebula, a region in Monoceros. Stars called the Jewel Box. A stellar cluster. Splendor in Sagittarius. The galaxy Centaurus A. Spiral galaxy NGC 2997. A galaxy whose light took 10 million years to reach the mirror of the Anglo-Australian telescope.